All right. Happy Monday, sixth grade. I'm looking forward to jumping in with you guys for your fourth day of virtual school, your first Monday and start to the week. I'm looking forward to jumping into new material on triangles. So last week we dove into finding area, discussing what area might be as tiles on a floor. We practiced on some very strange shapes with partial units and combining and rearranging parts. And then we took all those skills and applied them to parallelograms to be able to find the area of some unique shapes that we haven't practiced with, like the one behind me that we did on Friday. Now, we're going to do the same thing, practicing some new strategies, but this time to find the area of triangles. Now, the area of triangles is got a pretty simple formula, one that you'll memorize and probably know by heart as you progress in this unit, but we're not going to dive into practicing with that formula until tomorrow. And the reason that I'm doing that is so that we can gain an understanding of how a triangle relates to other shapes, because it's going to grow you in your understanding of shapes and geometry in general, but it's also going to help you with that problem-solving skill that you all are growing in. So to start, one of the initial strategies that we can use to find the area of a triangle is to double it and form a rectangle. So for instance, in this triangle here, this is a unique style or type of triangle, and if you're familiar with your vocabulary, you know this is a right triangle. It has a 90-degree angle. You can see it has a perfect corner. This makes it the perfect triangle to create a rectangle with, because all I would need to do is take this triangle and take a second copy of it, placing it on top to form a rectangle that looks like this. So this diagonal line cuts the rectangle perfectly in half, and I have one triangle and another triangle to squish together and form a perfect rectangle. Ms. Rebler, why is that helpful? That seems like more work. Well, it seems like it, but you all have been very good at knowing what the area of a rectangle is. You multiply length times width. It's pretty simple. So when we take this triangle and double it, we're doing that to see what the area of its counterpart might be, and then we can find and scale back what the area of the original shape was. So length times width, 8 times 2, is 16. And so the area of this rectangle here is 16. And if I wanted to zoom in and find the area of only the blue part and not the entire shape, I would take 16 as my total and cut it in half. And the reason why I would cut it in half is because originally I doubled my triangle. So to go backwards, I would have to half the area of 16 to find the initial shape, which is 8. So the area of this original triangle that we started with would be 8. So this strategy to double and form rectangles comes in handy, especially when you're just finding the area of a shape quickly. Notice you couldn't count up the squares here if you tried, and some of you did that in your cooldowns. These partial triangles are really hard to calculate, and they're impossible just using your eyes. So to be exact and use this doubling strategy is a good way to use just your mental math. Now, some triangles don't form perfect rectangles. For instance, this one. If I double this triangle, because it doesn't have a right angle at the top, all of these are acute angles, being an acute triangle, then it won't form a rectangle. It will, however, form a parallelogram. And so as you see in this example with this parallelogram, we've already learned that you can find the area of a parallelogram by multiplying base times height. So here, the parallelogram's base is 4, and its height, if I count up the middle, is 6. So the area of the entire shape is 24. 6 times 4 is 24. And just like the first example, if I want to find only the blue triangle, because I doubled to get 24, I'll have to find my answer. 24 cut in half right at this diagonal line means that the blue piece is 12 and the orange piece is 12. So the original area of this triangle is 12. Pretty simple, right, when you get to practice it. Now, going to that strategy we've looked at with parallelograms, we can take a triangle and we can decompose it and then rearrange it, right? Or cut it and then paste its parts back together into a shape that we like better. So because we're getting familiar with parallelograms, I can easily take this triangle here and I can cut it right at this dotted line to form a parallelogram. Now, one thing I want you to notice, they didn't just put this dotted line anywhere. They put it directly in the halfway point of the triangle. Notice that the triangle is 1, 2, 3, 4 units high. And so the dotted line appears halfway at the midpoint of the triangle. So by cutting off this tip of the top, I'm going to move it, like I see here, and add it onto the side of the bottom half, creating a parallelogram. Notice I have a parallel side, a parallel top, and a parallel bottom, making it a perfect parallelogram. Now, the way that this is different than my previous examples is I did not add any new area here. I have only moved and shifted the area around. So there won't be any halving of the area that I find because I didn't add any imagination to the area I see here. It's all from this original figure, just put in a new place. So I can use this strategy, just like I did in the previous example, to find the area of the parallelogram. The base is 1, 2, 3, 4, 5, 6. The base is 6, and the height is 2. So my base times height, 6 times 2, is 12. And like I said, because this parallelogram is made up of all of these original pieces, if this parallelogram is 12, then this triangle is 12. Now, one final strategy that you may see that some students like to use is to form a rectangle around the triangle and then scale back from there. Now, I'll be honest, this isn't my favorite strategy, and that's simply because you're putting a little extra steps on yourself that you don't necessarily have to do. But some students really like to make things look like a rectangle. And so if you don't have a right triangle, like this one is an acute triangle here, and you want to make a rectangle and use your length times width, you can. You just have to do a couple extra steps. So let's take a look. Here I have a triangle with a base of 6 and a height of 3. And if I'm going to box it off and make a rectangle, it will look like this second shape here. So this extra orange space is additional. That's not part of the triangle at all. And if I multiply 3 times 6, I'll see the entire shape, this rectangle, is 18. Now, the only thing about this and the strategy that it's not my favorite is because I can't just take 18 and cut it in half like I did in my other strategy to say that the triangle is 9, because this isn't exactly half, because I didn't double anything. I just enclosed it in a rectangle. So the way that we'll determine what the blue space is we're going to have to form it into parts where half are blue and half are orange, and then take the halves from there, and I'll show you what I mean. If you notice, this portion of my rectangle is perfectly split, half orange, half blue. And this portion of my rectangle is perfectly split, half orange, half blue. So what I can do is say, well, this rectangle is a 3 by 4. So that's 12. And half of that, so just the blue, is 6. And on this side, I have a 2 by 3. And half of that, so 2 by 3 being 6 units, half of that is 3. So if this 12 divided by 2 is 6, and this 6 divided by 2 is 3, then I have 6 and 3, that's 9. Sorry that I didn't put the math on the slide. If you need to go back and rewind it and write what I'm saying, that may be more helpful to you. I didn't put the formula written up at the top, and I probably should have. So I took half of this rectangle, which was 12, and half of this rectangle, which is 6. 6 and 3 makes this 9. So the area of this rectangle is 9. Now, like I said, This isn't my preferred strategy, but your brain may love it and just eat it up. So I want you to know how to do it in case you do end up enjoying it. So to highlight our two most common strategies, first one, we talked about how you could double a triangle. So in this example, I'm going to take my triangle, a 3x8, and I'm going to double it and make it into a parallelogram, like this shape is here. Then I can find the area of my parallelogram by using my formula of base times height. My base is 3, my height is 8. 3 times 8 is 24. But remember that the triangle is half of this larger parallelogram. So if this big shape is 24 and the triangle is half of that, half of 24 is going to be 12. So this interior, this yellow space here would be 12. Now another strategy we looked at was to decompose the triangle and rearrange it into a parallelogram. So in this, we're going to cut off the top half of the triangle. Notice they cut the 8 feet into 4 feet and 4 feet so that they could match them up perfectly and make a parallelogram. Once we've pasted or rearranged this top portion into the shape of a parallelogram, we can then find the area of the parallelogram using our formula base times height. So the base is 3, the height is 4, 3 times 4 is 12. Notice I don't have to do any extra division here or cutting things in half because I never added more area. On this, I doubled the shape, so I have to half it to find the yellow piece. Whereas here, I didn't add anything that was additional, I just shifted the pieces around so I could see them in a new way. So in both of these, because they're the same triangle, I have an area of 12. I just tackled it in a different way. Okay, I want to thank you guys so much for your consistent effort. I want you to feel free to rewind this video and go back and refresh your mind. If there was a part of it that you did not understand at all, please feel free to message me on GoGuardian or text or call. Quick note, I'm available on GoGuardian chat until 11 a.m. And then after that, I'm going to be kind of on and off the computer since I'm chasing Josiah around all day. So if you really need to get a hold of me and I'm not answering on another platform, please call me or text me. My number is posted all over the place, and I'll make sure that every day you have access to it. So thank you so much, guys, for your work. I really am grateful for all of you, and I look forward to seeing your amazing cool downs that you start to work on today.